Let us start 21st lecture of this course. And today we are going to discuss on another tool of soft computing family, that is neural networks. Now the topics which I am going to discuss are as follows. I'll give a brief introduction to the working principle of a biological neuron. All of you know that our brain consists of a large number of neurons. Okay, so we'll see the working principle of a biological neuron and how to copy the principle of a biological neuron in the artificial way so that we can design the artificial neurons. Now, once you've got the artificial neurons, we'll concentrate on the networks, that is the artificial neural networks. In short, this is known as ANN. Now, if you see the neural networks, there are two types of learning technique which we generally use. One is called the supervised learning and another is your unsupervised learning. I'll be discussing in details the principle of both supervised and unsupervised learning, and then I'll concentrate on two forms of supervised learning. One is called the incremental training, another is called the batch mode of training. So in today's class, I'm just going to give introduction to the artificial neural networks. We everything from human being, we copy everything from nature. Okay, so our brain will be modeled in the artificial way in the form of artificial neural networks. Now, before I go for discussing that, let me try to give some information. Like the concept of neural network was proposed by Makla and Pitts in the year 1943. Now, as I told, that biological nervous system or human brain consists of a large number of neurons, and these neurons are working in parallel. We have got approximately 10 raised to the power 11 or 10 raised to the power 12 neurons, and of course it will vary from person to person, and all such neurons are working in a parallel computing mode. Okay, and that is why our brain is a highly complex parallel computer. Okay, so the neurons are working in parallel, they are passing instruction to the next neuron. How can it pass? That I'm going to discuss in details. Okay, and ultimately our brain can take the decision, might be within a fraction of second. Okay, so all such things I'm going to discuss in details. Now, biological neuron, all of you have studied in your school level, okay, that our nervous system or the brain consists of a large number of neurons, and each particular neuron consists of dendrites. Dendrites are nothing but a bush of thin fibers. Then we have got cell body, which is also known as soma. Then we have got axon. Axon is a long cylindrical fiber. Then we have got the synapse, that is the junction between one neuron and the neighboring neuron and others. A picture of a biological neuron, you'll understand. So this is a biological neuron. Now here I have got some neighboring neurons. Okay, here also I have got some neighboring neurons. Okay, now with the help of these dendrites, the thin fibers, this neuron will collect information from the neighboring neurons. Okay, and all such collected information will be summed up here in the cell body or soma, and this collected information will pass through the axon hillock, and then it will go through the axon. Axon is nothing but a long cylindrical fiber. Now at the end of the axon, there will be some branches. You can see now these particular branches of the axon will be in touch with your dendrites of the neighboring neuron. Now this connecting zone, this junction or the connecting junction is known as the synapse. So synapse is a connecting junction between the end of the axon and the beginning of dendrites of the next neuron. So this is actually your the synapse zone. Okay. Now, so this biological neuron consists of dendrites, cell body or the soma, axon, and the synapse. Okay. Now, the working principle of this particular biological neuron has been copied in the artificial way in the form of artificial neuron. So, I'm just going to introduce the concept of artificial neuron, and you will see that the working principle of a biological neuron is copied there in the artificial way. Okay. Now let me just concentrate a little bit on this particular synapse part. Now, as I told, the synapse is a region, the common region between the axon of one neuron and the dendrites of the next neuron. And through this particular synapse, the information collected with the help of dendrites, okay, so that will be passed to the next neuron. Either 100% of the information collected will be passed, or certain percentage less than 100% will be transferred to the next neuron. Now in biological neuron, how does it transfer? What is the principle? The principle is very simple. Here, there will be some difference in ion concentration, like sodium ion, potassium ion, and all such things. And due to the difference in sodium and potassium ion concentration, Na plus and K plus, okay, some part or 100% of the information will be transferred from this particular neuron to the next neuron. Okay. Now you might have heard one problem with the aged people. Okay. There could be some deficiency of sodium ion and potassium ion. And due to this deficiency of sodium ion and potassium ion, the enough information is not passed from one neuron to the next neuron. Okay, because the ion concentration at this particular zone of the synapse decreases, and consequently most of the information collected by one neuron is getting lost, and it is not being transferred to the neighboring neuron. And that is why there could be some inconsistency in their behavior also if there is any deficiency of sodium ion and potassium ion. Please stop your audio and video. Please stop your audio and video. Hello, please stop your audio and video. Stop your audio and video. Now let us see how to copy the working principle biological neuron in the artificial form, in the form of artificial neuron. Okay, now I am going to concentrate on a particular artificial neuron. Now here you see the inputs are denoted by I1, I2, I3, I4, IN. So there are small n number of inputs collected with the help of dendrites. If you concentrate here, so this information is collected with the help of this particular the dendrites. Okay. Now the information collected with the help of dendrites, that is I1, I2 up to IN, those things will be multiplied by the corresponding connecting weights. Okay. For example, say whatever is collected as I1, that will be multiplied by W1J. I2 will be multiplied by W2J and so on. And this particular IKWKJ, so this multiplied thing, those things will be summed up here in the summing junction. You can see that summation k equals to 1 to n IKWKJ. And then we are going to add a bias value, that is your Bj. And what is the purpose of using bias? That I'm going to discuss. So we try to find out summation k equals to 1 to n IKWKJ plus Bj. So this is nothing but the total input, that is nothing but Uj. So here I'm just going to concentrate on a particular neuron, that is nothing but is your the jth neuron. So the summing junction, this summing junction is nothing but is your cell body or soma of the biological neuron. Okay. And the input coming out or the output coming out from the summing junction is Uj. And this Uj information is passing through the action of the biological neuron, and then it will go to the synapse. So this activation function or the transfer function is going to represent the synapse of the biological neuron. Now here there will be some mathematical function I will be discussing in detail, that is called the transfer function or the activation function. Now this Uj will enter as the input to the transfer function, and consequently I'll be getting some output, that is your Oj. So I'll be getting some output Oj, that is nothing but f of Uj, that is nothing but f of summation k equals to 1 to n IKWKJ plus Bj. So this is the way actually we can find out the output of this particular the jth neuron. Okay, so now you can once again refer back to the biological neuron. Okay, so this is the biological neuron, and the working principle of biological neuron has been copied in the artificial way in the form of your artificial neuron. Okay, I hope all of you have understood the similarity between a biological neuron and an artificial neuron. Now, a few things I want to add here. For example, say here we are introducing some connecting words. What is the physical significance of the connecting words? See, with the help of dendrites, I'm collecting information. Neuron is collecting information. Now, remember one thing, all the neurons, sorry, all the dendrites may not be able to collect 100% information always. Supposing that, take a very hypothetical example, but practical example rather. Supposing that your brain is getting tired, okay? So you are working throughout the day, might be at the end of the day, okay? So your brain is getting tired, okay? So your dendrites are not working properly. Are you getting my point? So if the dendrites get tired, it will not be able to collect 100% information from the neighboring neuron. Okay, what do? You take some rest, and if you take some rest, once again, dendrites will be activated. Okay, now, so depending on the situation, so this particular W will vary in the range of 0 to 1. If it is 1 means 100% information is coming. If it is 0 means no information is coming. Okay, so this is the significance of introducing this particular the connecting weight. Now, what is the significance of this bias value? Now here, although it is written Bj equals to 1.0, generally we keep a very small value for the bias. For example, say 0.01 or 0.005 and so on. Now, what is the purpose of adding this particular bias to the summing junction? The purpose is very simple. Supposing that all of your dendrites are getting tired and all the W values are very near to 0. Very hypothetical. You are too much tired. Okay, so your dendrites are unable to collect any information. Are you getting my point? then what will happen to this summation k equals to 1 to n I k w k j? That will tend towards 0, very small value. Okay. If it is very small value tending to 0, okay, now this particular computer program you'll have to write, you'll have to run it in the computer. Computer doesn't know anything of the physical problem. Okay, and supposing that so this particular part is tending towards 0, what will happen to this particular input if there is no such bias? So this input will become equal to 0. Are you getting my point? If the input becomes 0, it becomes difficult to get the output. Of course, it depends on the nature of the activation function or the transfer function. Just to avoid that particular situation in the computer program, okay, we just add a small bias value so that this particular uj does not become equal to 0. So we want to avoid that particular the situation. Okay, for example, it's very hypothetical. Supposing that the transfer function is such, that is nothing but output, that is OJ is nothing but, say is very hypothetical, say 1 divided by UJ. And supposing that there is no such bias value and UJ is becoming or tending towards 0, so what will happen to OJ? So 1 divided by 0, so computer is going to give you one result that is man, not a number. So we'll have to be very careful while writing down so that particular the computer program, and that is why it is accepted widely accepted that you add some small bias value. I hope you have understood the physical significance of putting this particular the bias. Okay. Now, if you have any doubt, we'll be discussing at the end, not now. Now, here, so this artificial neuron that is replaced by this particular symbol, that is the symbol of a circle. Okay. So if you see the artificial neural network, you'll see that that network consists of a large number of circles. Okay. So this particular circle is going to represent the summing junction and the activation function together. Okay. So this circle has got two parts. One is called the summing junction. Okay. So uj is nothing but summation of this I, k and w, kj plus the bias value, that is bj. Okay. So this part is the summing junction part, and here we have got the transfer function. The moment I am passing I1, I2, I up to In, and we have got this particular the connecting words, okay, and we multiply the inputs in the connecting words, sum them up, add the bias value, that will become equal to uj, and it will pass through the transfer function, and consequently you will be getting that output, that is your oj. So this is the way one artificial neuron works. Okay. Now, if you see the literature, we use different types of transfer function. For example, say hard limit transfer function. We use linear transfer function. We use log sigmoid transfer function, tan sigmoid transfer function, or any other non-linear transfer function. So I'm just going to the different types of transfer function which are generally used in artificial neural networks. So I'm just going to start with a hard limit transfer function. Okay. So this is the hard limit transfer function. For this hard limit transfer function, the output will be either 1 or it will be 0. Okay. Now this is the input U and this is the output O axis. So this output is either 0 or 1. That means it is either yes or no. That means either 1 or 0. Okay, so this is some sort of on and off type. Okay. Now this output equals to 0 if u is less than 0. You can see that output equals to 0 if u is less than 0. Otherwise, the output is 1.0. So either it is 0 or it is 1.0. Either it is off or on. Okay. So either 0 or plus 1. This is called the hard limit transfer function. Now then comes your the linear transfer function, uh, the straight line y equals to x. Okay, so here this is the input side u, this is the output side o, and y equals to x. That is your output is equals to input. That means your y equals to mx, m is equals to 1 here, but you can take some m not equal to 1.0. Okay, and you can also optimize what should be the most suitable value for this particular your m. Now, if I know this particular input u, I can find out the output of the transfer function. So this type of linear transfer function is used in a special type of network, or generally in the input layer, we use this type of linear transfer function for almost all type of neural networks. Okay, you might have heard about one network that is called linear filter sort of thing. Okay, so there we use this type of network very extensively. Then comes your log sigmoid transfer function, and this is the mathematical expression of log sigmoid transfer function. Okay, that is O is equals to 1 divided by 1 plus e raised to the power minus au. So a is actually a constant, and this particular constant is going to represent actually the slope of this particular curve. Okay, the higher the value of a, the steeper will be the curve, and so on. Okay, now if I consider a particular value of u, say u equals to 0. If I put u equals to 0, so this will become 1 divided by 1 plus e raised to the power 0. Now e raised to the power 0 is nothing but 1. So 1 divided by 2 is 0.5. So corresponding to u equals to 0, so I'll be getting the output, that is your 0.5. Okay, and this is the distribution, and this corresponds to 1, this is 0, and definitely this is a log sigmoid, so this is not going to go to the negative side. The range for this particular O is nothing but 0 to 1. Now then comes your the tan sigmoid transfer function. Now this is the mathematical expression for tan sigmoid transfer function, that is output O is nothing but e raised to the power au minus e raised to the power minus au divided by e raised to the power au plus e raised to the power minus au. Okay. Now a is a positive quantity which is going to represent the slope of this particular curve. And once again, the higher the value of a, the steeper will be the curve, and vice versa. Now, if I consider a particular value of u, say u equals to 0, what will happen? E raised to the power 0 is 1, minus e raised to the power 0 is once again 1. So 1 minus 1 is 0. 0 divided by, here I will be getting 1, 1, 2. 0 divided by 2 is 0. Okay. So corresponding to this particular u, I can find out your the output is equals to 0. So this is a tan sigmoid transfer function, and the output varies from -1 to +1. You can see that this is -1 and this is your +1. Okay. So these are the very frequently used transfer function. But as I told, that there is no hard and fast rule that you'll have to use only this transfer function. You can use some other type of transfer function like Gaussian transfer function or your some sort of polynomial transfer function you can use in neural networks. Okay. Now, once I have seen the working principle of one artificial neuron, now I'm just going to consider a layer of neurons. A layer of neurons consists of a large number of neurons. Okay. Now, for example, here you can see we have got say one neuron, another neuron, and we have got the pth neuron. So this particular layer consists of small p number of neurons. This is nothing but a layer of neurons. Okay. And these are all connecting words. These connecting words are written in the form of matrix. Okay. Now output OK is nothing but the function of summation j equals to 1 to n ij w jk. So these are all inputs multiplied by the connecting words, and I am adding the bias value. Now function of this is nothing but the output of k. Okay, so output of kth neuron is nothing but this. So I can define a layer of neurons, and I can also find out the output of a layer of neurons. Okay, now I'm just going to concentrate on a particular multi-layer neuron, that is nothing but your artificial neural network. Now this shows the picture of an artificial neural network, and this is nothing but a 2-3-1 network. This is the input layer, and there are two inputs I1 and I2. So these two inputs will pass to the input layer. This is the hidden layer consisting of 3 neurons, and this is the output layer. And for simplicity, I have considered only one output neuron. Okay, and this is the output. Supposing that I am modeling a process having two inputs and one output. So very easily we can design. So this type of network, that is nothing but 2-3-1 network. Okay. And here the connecting words between the input layer and the hidden layer are represented by V matrix, and the connecting words between the hidden layer and the output layer is represented by the W matrix, and B is nothing but the bias value, and for simplicity I have considered the same value of bias. Generally it is considered the same value of bias for all the neurons. Okay. Now, so this is a typical example of an artificial neural network which consists of three layers: input layer, hidden layer, and output layer. And each particular layer consists of a number of neurons. Okay. So I hope this particular structure is clear to all of you. How to carry out the analysis for a set of inputs, how to find out the output, those things I'll be discussing in future. Okay. Now, if you see the literature, we have got two types of network. One is called the static neural network, and we have got the dynamic neural network. Now, the performance of a neural network depends on the architecture. That means like how many layers are there, okay, what is the number of neurons lying on each layer, that constitutes actually the architecture. And of course, it depends on the connecting weights. Now remember, in the last slide, I showed one very simple neural network which consists of only one hidden layer. But truly speaking, there could be more than one hidden layers. Sometimes we use two hidden layers, three hidden layers, but generally you do not go for more number of hidden layers. Okay, just to avoid the computational complexity, and moreover, it may not be required also. Okay, now once the architecture is defined, architecture of the neural network is defined. And if you know the connecting words, if you send the set of inputs, you'll be getting that particular the output. Okay. And once you've got that particular output, if you compare with the target output to find out the error, and if you use the feedback device so that this error can be brought back to here for the modification of the architecture of neural network and connecting words, this type of network is known as the dynamic neural network. So in dynamic neural network, we try to compare the output of the network with the target output, try to calculate the error, and this particular error is fed back to the network to modify its architecture and to update its weight. That becomes a dynamic neural network. On the other hand, if you consider a static neural network, there is no scope for error feedback. Okay, so if there is any error in the network, the error will be there. There is no scope for error compensation in case of static neural network. Okay, so I hope you got the difference between static versus dynamic neural network. Okay, so now we are going to concentrate on the dynamic network, because in most of the cases, actually we take the help of the dynamic network, because we want to get the output as accurately as possible. Okay, now how to design this particular your dynamic neural network, that I'm going to discuss. Now, if you see the literature, you'll see that neural network is trained using two different learning approaches. One is called the supervised learning, another is called unsupervised learning. Okay. Now, this supervised learning is nothing but learning with a teacher. Huh? Like if you are going to make any mistake, your teacher is going to help you to correct that. Okay. So if the student is making any mistake, teacher is going to help him or her to make the correction, because this is the supervised learning. So if there is any such error, that will be modified by the teacher, and the teacher is going to help that particular student. That type of training is known as the supervised training or supervised learning. The principle of supervised learning is as follows. The outputs of the network are compared with the corresponding target values, and the error is calculated, as I told. It is then fed back to the network for updating of the set. Okay, that is called the supervised learning or learning with a teacher. That means I have got some available training data. So I have got my teacher to correct me. So if I am doing any mistake, so that particular available known input output relationship, which is nothing but the teacher, is going to help the network that you rectify, so that you can predict as accurately as possible. On the other hand, in case of unsupervised learning, that is nothing but learning without a teacher. There is no teacher. If you are going to make a mistake, you do self-analysis sort of thing and try to rectify. Okay. And there is no teacher, no training data to give you the feedback so that you can rectify. Okay, that is called learning without a teacher. Okay, now if there is no such teacher to help you during the learning process, so you'll have to take the help of competition, cooperation, and updating. Okay, so the principle of this competition, cooperation, and updating, I'll be discussing in much more details while discussing your the self-organizing map. And as I've already mentioned, that our brain most of the time works based on the self-organizing map. What is the reason? The reason is very simple. For most of the problem, the known input output relationship, that particular data is not available to us. Most of the time, your teacher is not available. So you'll have to rectify yourself if you are doing any mistake so that you can improve your situation. You can update your condition. Okay. The principle of competition, cooperation, and updating, as I told, I will be discussing after a few classes in much more detail. And you'll see that most of the time our brain takes the principle of unsupervised learning. Okay. So that is very interesting. In fact, the principle of unsupervised learning using the principle of competition, cooperation, and updating. Now I'm not going to spend much time on this because I'll be might be concentrating one hour full discussion on the principle of competition, cooperation, and updating while discussing your the self-organizing map. Uh, so this is your the supervised learning and unsupervised learning. In fact, my knowledge in soft computing is some sort of unsupervised because I did not get any opportunity to take a course the way you are taking. During our days, there was no course on soft computing. So my knowledge is some sort of unsupervised. Okay. So we had a lot of thinking, a lot of work, so many such programs, so many problems are solved. Okay. And based on that particular experience, I could write that textbook. I could develop the NPTEL lecture, and I'm teaching you people. Might be starting from 2003 till today. Okay. So this is the difference between the supervised learning and unsupervised learning. Okay. Now I'm going to concentrate a little bit more on the supervised learning. Okay. How to provide the supervised learning. Now the supervised learning can be provided in two ways, two modes. One is called the incremental mode of training. Another is called the batch mode of training. Now try to understand carefully the principle of incremental training. And this incremental training is also known as your online training. Okay. Now let me read it out first. Then I'll be discussing further. In case of incremental training or online training of the network, okay, a particular training scenario is passed through the network. Output or outputs are calculated, and then error is determined by comparing those outputs with the target values, and this particular error is propagated back to modify the network. What does it mean? It means that, let me just go back to the picture of neural network. Say this is a very simple network having two inputs and one output. Okay. Supposing that these connecting weights initially generated at random, and the range for this connecting weight either 0 to 1 or from -1 to +1. Okay. Now, so these connecting weights are generated at random, say, and we know this particular bias value. The moment we pass one set of inputs, that is I1 and I2, okay, so gradually I'll be getting this particular output. How to get it, that I'll be discussing in detail in the next class. Okay, so supposing that I'm passing one set of inputs and I'm getting this particular output. Okay, now you see the connecting weights are generated at random, and there is no guarantee that the output which we are getting is exactly matching with the target output. So there could be some deviation, some error. Now this particular error will be fed back and the connecting weights and other design variables, those things will be updated so that we can get a very accurate prediction of this particular the output. What is our aim? Our aim is to get a network which will be able to predict the output for a set of input as accurately as possible. But unfortunately, we are getting some error, and our aim is to minimize that particular error. So this particular error is fed back to modify this connecting weights and other design variables. Okay, uh, mm, so that we can get the error-free prediction. Now, if this particular updating of the weights and updating of the design variables are done your training case Y. For example, I am passing one training scenario. I'll be getting the output. I'll be getting the error. Using this error, if I update the connecting weight once, I'll be getting a modified network. Then I'm passing not the first training scenario. I'm passing another, say, second training scenario. Okay. Once again, using the modified connecting weights and design variables, I'll be getting some output. And once you get this particular output, okay, once again you compare with the target, find out the error, and this error is fed back. And if you just give feedback, so once again, I'll be able to update this particular the connecting weights. Then I pass the third training scenario, you update the network. Fourth training scenario, you update the network. Okay. So after passing a particular training scenario, I'm updating that particular the network. This principle is known as the incremental mode of training. And that is also known as online training. Okay. Now, if I've got 10 such training scenario, after passing the first training scenario, I'll be getting one updated network. After passing the second training scenario, I'll be getting another updated network. After passing the third training scenario, I'll be getting another updated network. So the moment I'm passing one training scenario, I'll be getting a new updated network. Now, which one to be believed for the final application? Okay, so it is hard to take that particular the decision. So this is actually the drawback of incremental mode of training. But this is applicable if and only if you do not have the sufficient number of training scenarios and we have got only say the 10 training scenarios or 15 training scenarios and you want to use the network online, okay, so you'll have to go for so this type of incremental mode of training. I hope this is clear to all of you. Now another is your the batch mode of training, that is also known as the offline training. Okay, the principle is as follows. The whole training set consisting of a large number of scenarios is passed through the network and an average error in prediction is determined. The network will be updated based on this average error. What is the principle? Let me go back to the figure once again. Say I have got, it's very hypothetical. Say I have got say 1000 training scenarios for this particular the network. Or let me consider I have got say, let us make it simple. I have got say 50 training scenarios for this particular network or 100 training scenarios. So what I do is out of 100, the first one I'm going to use once again initially connecting weights and other design variables will be generated at random using the random number generator. So out of these 100 training scenarios, the first training scenario I'm sending to the network. So I'll be getting some output. This calculated output is compared with the target output and the error is determined. Okay, you store that particular error value corresponding to the first training scenario. Then you go for the second set of training. Once again, you pass through the network, you will be getting one calculated output. Compared to the target output, you will be getting one error or deviation. You store it corresponding to the second training scenario. Go to the third training scenario, third training case. So once again, another deviation value you'll be getting. Okay. Now, till now, I have not updated this particular the network even once. So what I do, I'll pass all 100 training scenarios one after another. Okay, through this original network or initial network. So here I'll be getting 100 numerical values corresponding to the deviation in prediction or 100 error values. So what I do is you now this particular error value, sometimes the calculated value will be more than the target and sometimes the calculated value could be less than the target, depending that this particular deviation will be either positive or negative. Take the mod value, okay, of this particular the deviation. You sum them up for all 100 training scenarios. Okay, so you'll be getting one average error value or one average deviation value. Okay, now based on this average deviation value, okay, the mod value of that, okay, average you consider. So based on this particular average value of the error, you update the network one. Okay, once again, you send all 100 training scenarios through the updated network. Once again, you collect here all 100 values of deviation or the error. You find out the average error or the average deviation, and based on that, you once again pass all 100 training scenarios. The moment you pass 100 training scenarios, you'll be getting 100 error values, find out the average. This particular average value of the error, you propagate it back to modify or update the connecting words or this particular the network. The moment I'm passing 100 training scenarios to this particular network, and based on the average value of this particular error, I'm updating the network. Now this is called one epoch, EPOCH, one epoch of this particular the network. So after passing 100 training scenarios to this particular network, I'm going to complete one epoch of this particular algorithm. Okay, and this particular process will go on and go on, and it will run for a large number of epochs. Okay, just to give you what could be the updated or the modified network or the final network. And once you have trained that particular network, okay, now you can use it for online prediction for the test scenarios. This is the principle of your the batch mode of training. Now, a few comments I want to make on the batch mode of training. Okay, and I have seen many people for making mistake in this particular the batch mode of training. But being the students of my class, you people should not make that type of silly mistakes. Okay, let me take a very simple example. So in mathematics, supposing that you have got a set of equations involving 10 variables. Okay, now if you want to solve for 10 variables, what is the minimum number of equations you need? The minimum number of equations you need is 10. So we need 10 or more than 10 equations, okay, to solve for 10 variables problem. All of you know that. If you get 9 equations, 10 variables, nobody in the world will be able to solve it. Okay. But if you have 10 variables, but 11 equation, 12 equation, there is a possibility you will be able to solve it. Okay. But supposing that I've got 10 variables, 10 unknowns, and I have got 100 equations. Might be you people will be in trouble to solve it. Are you getting my point? So if there are 10 unknowns, I need a minimum of 10 equations or slightly more than 10 equations. But we do not need 100 equations. And if you get 100 equations, you are unfortunate, I should say, you'll not be able to solve it, or it becomes a difficult problem for you to solve. Same is true for the batch mode of training in the neural network. Okay. Now, what you'll have to do is, in batch mode of training, as I told, that a number of training scenarios are to be passed through the network. But what is the number of that particular training scenario? How to decide that number of the training scenario? Okay, that is very important. See, your neural network doesn't know anything regarding the physical problem. So if you make any mistake while designing, while modeling that particular network, your network is going to give you some results, but that result may not be the correct one. Okay. Now I'll just take one example. Supposing that there are 50 design variables consisting of the connecting weight, the coefficient of transfer function, and bias value. You just add them up. Let us suppose there are 50 such unknown variables. If there are 50 such unknown variables, what should be size of the batch mode of training, the training size? It should be at least equal to 50 or slightly more than 50. Okay, it cannot be 49, that means less than 50. It cannot be 250, 300. Are you getting my point? I hope you got this particular idea. But I have seen a number of papers published in so-called very good international journals where this particular principle is violated. Okay, they have used batch mode of training with insufficient data size, training size. But they are reporting results. Papers are also accepted. They got published also. But there is a fundamental mistake in those particular works. I've seen many, many such papers in so-called good international journals. But don't make this particular mistake. The reason I have already told from the mathematics. Okay. Now let us see what happens if the number of training scenario becomes less than 50 and if the number of training scenario becomes much larger compared to 50. Both are bad. If it is less than 50, as I told, neural network doesn't know anything of the physical problem. It will once it is trained, it will give some result. But that is a case of under training. Okay, because sufficient number of training scenarios we could not provide. Okay, that is called the under training of the network. Now, what do you mean by overtraining? If you just use a very large number of training scenarios, might be the network will be confused. Okay, see what is the purpose of training of this particular network? So that the network can capture the trend of that particular input output relationship. Now, unnecessarily, if you use a very huge number of training scenarios, might be your network will be confused. And if there is any such overtraining, there is a chance of vomiting tendency of this particular the network. What do you mean by this vomiting tendency? Vomiting tendency means your if you just give so much training, overtraining, okay, the adaptability of this particular network will be lost, and whatever has been trained, the same thing will be reflected on the output results. Okay, no such adaptability is going to grow. Okay, what do you mean by the adaptability of this particular the network? I'll be taking one very practical example, but you'll have to give me the word you are not going to mind. Okay. Now your training and placement time is coming. So we, from our institute, we try to sell our product, that is our BTech, our dual degree students, our MTech, our PhD. Okay, in fact, we sell our product to the different companies. Okay, now the BTech has got a brand value, dual degree has got a brand value, MTech has got a brand value, and our PhDs are having another brand value. Okay. Now, if I concentrate on a particular brand, for example, say the BTech of IIT Kharagpur has got a brand. Okay. Now, that is what? That is the average brand. Okay. Now, in that particular group or the batch, there could be a few students who could be much, much better compared to the brand. There could be a few students who are little bit weaker compared to the average status of the brand. But we are going to sell you people, okay, as the BTech brand, and till today we are getting very good response, okay. But whenever we say we sell our student to get their employment and others, we try to show this is our BTech brand, this is our MTech brand, this is our PhD brand. So whenever we talk about the brand, as if we consider the average effect. Okay, this is a very practical example. And as I told, please do not mind after hearing this particular example. Okay, this is the most practical example, in fact. Okay, now how do you decide that particular brand? To decide the brand, we consider the overall, all the BTech students, all the MTech students, all the PhD students to decide that particular brand. Same is true here in batch mode of training. Out of 1000 training scenarios, not all the training scenarios could be equally good. Okay, but we train the network based on the average effect of this particular error. Okay, that means this particular network during the training is going to get some sort of adaptability. Are you getting my point? So that particular adaptability has to be ensured through a proper the batch mode of training. Okay, so whenever you are going for the batch mode of training, you'll have to be very much careful about the number of training scenarios. What we do is very simple. You see the number of unknowns, the number of design parameters, okay, like number of V's, coefficient of transfer function, and B. Accordingly, you select the number of training scenarios. Number of training scenario cannot be less than the number of unknowns. It has to be either equal or slightly more compared to the number of variables, but it cannot be your too large. I hope I'm clear to all of you. Let me take another very, very practical example. Okay. Now on 20, just a minute, no, 14th. So 14th October, your second test will be held. Okay. Now my question is, how many times you are going to revise the course, like whatever has been taught after the first test, and up to whatever will be taught up to tomorrow's class. Okay, how many times you are going to revise so that you can perform in the optimal sense? Are you getting my point? So what is the number? Syllabus is small. Some students will be like revising 10 times. Some students will be revising only once. Okay. Now, what is the optimal number of revision so that you can perform well in the exam? Can anybody say? It is very difficult to say. Okay. Whether the 3 revisions will be okay, whether the 4 revisions will be okay, or 8 revisions will be okay, or only 1 revision will be okay. Remember, there is one optimal number of revision, okay, which is required if you want to perform in a very good way during the exam. Okay. Now, supposing that optimal number is 4, it's very hypothetical. That means the optimal now, the 4 times if you revise, there is every possibility you'll be getting say 20 out of 20. Okay. Now, what happens if you revise 8 times? If you revise 8 times, there is no guarantee that you will be getting 20 out of 20, provided you do not copy from others. Okay. Now, if you want to get 20 out of 20, what is the optimal number of revision? Say 4. And if you revise 8 times, there is no guarantee you'll be getting 20 out of 20. What is the reason? The reason is the more the number of times you revise, there will be overtraining. Your network is going to get overtraining. Okay. And due to this overtraining, there will be vomiting tendency. And if I ask something which is not directly taught in the class, and if there is a little bit of twist in the question paper, you may not be able to solve that. Are you getting my point? Because overtraining has come, vomiting tendency has come. So if there is any such critical thing, you may not be able to enter into that particular thinking which is required to solve that particular numerical example. Okay, that chance is also there. On the other hand, if you just revise only once, there is every possibility you may not be able to answer all 10 MCQs. Okay, so I hope you have understood the importance of having the optimal number of revisions of the course before the exam on 14th. And knowingly or unknowingly, you are using actually the principle of neural network. Okay. So in fact, with this, I want to stop here today because we have got 2 meetings, big meetings. So today, actually, I'll have to stop here. But before that, if you have some small query, I can spend 2-3 minutes because our meeting is going to start from 10:15. So if you have any small query, we can or otherwise tomorrow's class, at the beginning of tomorrow's class, we can discuss on the query. Can I stop here today? Let me stop. So if you have any doubts, you note it down. And tomorrow's class, at the beginning of tomorrow's class, I'll try to first clear your doubts, then I'll proceed further. Okay, let me stop here today.